Hi, I'm Mark Hall with Rainbird, Area Specification Manager for Northern California, the Bay Area specifically. And we're going to talk about pumps today. And we're calling it Pump It Up. I do have a special guest sitting right next to me.
Hi, I'm Michael Thegamthoda. I'm the product sales manager for pump stations and filters for Rainbird in California. It's a pleasure to have you all, and thanks for taking your time to, go, giving us a chance to go through the pump webinar.
Pump It Up, special guest Mike T. I'm Mark Hall, Area Specification Manager for Northern California, Bay Area. How to specify a pump. We will talk about pump basics, project examples, our job information form, provided specs, and lead time.
Do you need a pump? If the dynamic pressure in exceeds the worst case pressure requirement out at the point of connection, a pump is not needed. But if the dynamic pressure in is less than the worst case pressure requirement out at the point of connection, a pump is needed.
Pump basics. How does it work? Hey Mike, what are you doing in there?
Hey Mark, I'm just pumping up my tires. So I'm just taking this trailer down south, so I thought I'll stop by to give you an overview of our pump station.
Excellent.
Okay, so first of all, let me give you an overall outlook of the components parts of the pump station. So here you can see the inlet where the water is coming through, and the green component is actually the heart of the system. This is the actual pump portion, which actually boosts the pressure of the system. And this is the discharge line, which goes to the outlet and connects to the irrigation lines. We do have a pressure gauge. Also, we do have an isolation valve, pressure transducers, and a pressure thermal switch as well. The other components which you see in the pump station is the variable frequency drive and the pump start relay, and all of these components are actually enclosed in like an enclosure. We do have different types and sizes of pump station depending on the sites, the irrigation sites out there.
That's all great. How does it work?
Okay, so I'll make it really simple. So water comes in through the inlet. The pump starts right when it gets a signal from the irrigation controller. So the signal comes onto the pump start relay. It sends a signal to the pump to start up. The pump will start up and boost the pressure. You can actually, when the pump runs, you can actually see the pressure boosting on the gauge itself. And once the pressure is boosted, it actually comes out through the outlet. So in between, there are some areas where there are communication. So depending on how big the site is, depending on how many zones, the flow required for different zones are different. So the pump ramps up its speed depending on higher flow zones, and the variable frequency drive is the one which is actually controlling the speed of the motor. And if it's a smaller zone, the pumps run slow. So it actually adjusts the flow rate to keeping that pressure boost required for the whole irrigation. Yeah, so any other more details would you like to know, or
No, I have no questions.
Okay,
you covered it all.
Okay, so would you like to join me for my road trip?
That would be great.
Awesome, let's go.
Project examples. Here we have typical school site, and as you can see in the vignette, the pump station is actually installed right near the curb of a parking lot area. So in the vignette, you can see that the pump station is connected after the backflow, and on the discharge line of the pump, after the pump comes the master valve, the flow sensor, and the gate valve, and the discharge line continues to the main line of the irrigation.
This is our job information form. We also call it a JEF. You'll see on this form that we have a number of items that we will need you to fill out so we can figure out the size and the type of your pump. We also have on there maximum flow and minimum flow. We'll need to know those items, and your power supply, and a number of others. If you need our help, please give me a call or send me an email, and I'll be happy to help you or walk you through this form.
Now let's go through a couple of different site conditions which you all may come across when you are designing a irrigation system. The first one, as you see, is a pressurized header. As you can see in the picture, the green area where there's the backflow, and right after comes the pump station, and the discharge line of the pump station go through the main irrigation line. We are actually seeing an above ground tank condition. We also call it a flooded suction. So the water level in the tank is above the water level where the pump station is located. So the water for the irrigation is actually fed by the water inside the tank, and then the pump boosts up the required pressure and supply it to the discharge line. In this slide, we are actually looking into a below ground tank condition or a suction lift condition, where the pump is actually installed on the top of the ground, and there is a suction tank where the water is stored, and we are pulling the water from the tank for the irrigation applications. Here we have a wet well installation where it's actually probably near to like a pond or a lake, where there is a connection from the lake to a wet well beside the lake where the pumps will be installed. It's very similar to the slide which we saw earlier, the below ground tank. So the water for the irrigation is actually used from an adjacent well or a lake. This is another example for a suction lift condition where we are actually pulling the water from a well, like a borehole well or a deep well, for irrigation purposes. So we have pump stations which can operate in these conditions as well. Here is another example for a suction lift condition where the water for irrigation is pulled from a lake. So the pump station sits beside the lake, and then there's some strainers involved, and then we get the water pulled into the pump and pressurize it for the irrigation purposes.
Flow range, very important item. This is information that you will need to place into your JIF form, job information form. Minimum flow, lowest flow, which could be a single valve or multiple valves that run at one time. And we'll need maximum flow, which is the highest flow, could be a single valve or multiple valves that run at one time.
Our pump station is always selected based on the pressure details in the irrigation plan, so it is really important to know the actual pressure details. So there is another factor as well. It's called dynamic pressure. The difference is static pressure is the pressure where there is no flow through the irrigation system. So basically there is no friction losses or anything taking place. Another factor we would like to know is the location of the pump station, which determines if we need an enclosure or not. So as you can see in the picture, On the left picture, if there is an enclosure for the pump station, and on the right side picture, it is installed in a pump room where we don't need a enclosure for the pump station. Another very important factor is the power specification at the site. Sometimes we may not know that when we are specifying the irrigation plants, but we could provide single phase or three phase power supply at different voltages from 208 to 230 to 480 volts. It's very important before the pump is installed to confirm this power specification, and you can have it as a note in your plans for the contractor to confirm this. In order to summarize what we just discussed, so what Rainbird can help you all in the specification process is we can provide the specs for the pump station. We'll be providing the cut sheets which will have all the details of the pump station, and also we are going to provide a typical drawings which you can put it in your plans. We can provide a PDF format or even DWG format. You can directly drop it into your plans.
Lead time. Our specification package that we can put together for you, we can do it in as little as 4 hours, small platform, 48 hours. If we have a medium or large platform, 72 hours, custom platform. Manufacturing timing, 3 to 6 weeks for small platform, 6 to 12 weeks for large or custom platforms.